This is Varun Dutt from IIT Mandi. We are learning about large applications practicum, and in this lecture, I'll be exposing you to Unified Modeling Language, which is a standard for documenting software more formally in industry and in the real world. So let's get started. So Unified Modeling Language is like the Bible, which is the diagramming language or which provides the notations which allows us to visualize the documents, which allows us to visualize the code in its static and dynamic sense. It is a must for industry for documenting code, particularly large applications code, and it allows us to create documentation for that code, both static as well as dynamically. So UML is designed specifically for object-oriented software design. UML is not a development method. It does not tell you what to do first, what to do next, and how to design your system, but it helps you visualize your design and communicate the design to others. So UML generally consists of a number of diagrams which are part of the software stack, and some of these diagrams are the use case diagram, class diagram, sequence diagram, collaboration diagram, state diagrams, activity diagrams, component diagrams, deployment diagrams, and entity relationship diagrams. Some of these diagrams like entity relationship diagrams, state diagrams, you may have already seen. These are kind of the diagrams which are used for documenting formally state machines and also database designs. In this particular lecture, we are going to focus on use case diagram, which is useful for capturing requirement, what the system is supposed to do, and class diagram and sequence diagrams, which tell us how the system is supposed to do it statically as well as when it runs. So, use case diagram is nothing but a use case is nothing more than a high-level description of what the product is supposed to do. So this basically defines the question what system is supposed to do and does not specify how it is to be achieved. And key terms in a use case are descriptions of the typical interaction between users of the system and the system itself, used to represent external interface of the system. Particularly, a use case is referring to the description of the interaction between users of the system and the system itself. And actor is an external entity, particularly which is outside the system, that interacts with the system by participating in a use case. And actors can be real-life people, for example, users of the system, or other computer systems or external events. So here is an example of an ATM use case where customers can check her balance, customer deposits money in his or her account, and such kind of use cases may exist. So let's see, this is a customer, this is an actor, and it basically, suppose the customer withdraws money from his or her account, so there is a withdrawal use case and it uses the login. So this uses is also called the stereotype, and oftentimes uses may also be mentioned as extends. So generally uses means that this particular functionality, withdrawal cash, needs to have login mandatorily. Whereas if it was extends, in that case, the withdrawal use case may or may not use login. So in this case, because it's a secure transaction, we need to have the login as uses functionality, or person needs to log in before a withdrawal can take place. And withdrawal cache is basically the case which will define what the ATM is supposed to do for withdrawing the cash. So typically what the system is supposed to do in a use case like withdrawal cache is captured in the form of a scenario, and there may be several scenarios for a use case. So this is the use case, customer withdraws cash, a withdrawal use case, and the scenario is successful cash withdrawal from checking account, which is a form of account like saving account. And so there are other scenarios possible like unsuccessful cash withdrawal and others. So generally a use case scenario for a use case starts with a precondition, that is customer is already logged into a system, and trigger, customer requests the withdrawal, and description, customer chooses a withdraw cash from the checking account, there's sufficient cash in the account, there is sufficient cash and receipt paper in the ATM, and the network is up and running. ATM checks the customer to indicate the amount of withdrawal, and the customer tasks spot $300, a legal amount to withdraw at this time. The machine dispenses $300 and prints a receipt, and the customer takes the money and the receipt. So this is what happens in the scenario in the use case, and the customer account is debited $300 because it was withdrawn, and the customer had $300 cash in his hand. So going from scenarios to classes. So if you capture the scenario properly, or if you capture the use case properly, the next is this thing which we need to do is to say how the system is supposed to do it. And one of the biggest stumbling blocks for many novices is finding out the initial set of classes or the objects and understanding what makes well-designed classes. One simple technique suggests writing out the use case scenarios and then creating class for every noun. Consider the following use case scenario. So this was the scenario: customer chooses withdrawal cash from checking, and this. So we first identify and bold all the nouns in the scenario, and we can write these down now. And then after a bunch of pruning, we can come up with non-overlapping categories like customer, cash, checking account, receipt, ATM, and net worth. And this would be the set of classes which will go into a class diagram. What is a class diagram? Class diagram provides how a system is supposed to do what it is supposed to do, but it presents a static picture, and how different classes that make up system and how they relate to each other is defined. Considered static because they show the classes along with their method and attribute as well as static relationship between them, which classes know each other, which classes are part of another class but do not show the method calls between them. So class is basically defined as an attribute and the method for a set of objects. So generally a class can be a class of students where the members are the students and the functions are take exam, come to class, and such kind of functions. All the objects of this class, instances of this class, share the same behavior and have the same set of attributes and the same set of functions accessible to them. So we will look at class diagrams in more detail ahead in the class. We have used these resources for creating the lecture. We will also be telling you about a software called Umbrello, which is a free software which can be deployed to make such diagrams, use case and class diagrams for free using API. And then Umbrello also allows you to create your code segments for the class diagrams created. So you can check the resources out. And this is now the time for activity. And in the activity, you need to first install Umbrello. If you're using a Linux machine, you do it this way. Otherwise, on Windows, one could go to the Umbrello website. And please note that this link may have changed. So you may search for Umbrello. And then once you search for Umbrello on the Google search, you can actually go and create use case diagram and try to use the diagram conventions which we have shown you the uses for the login case. And then you can save it in the XML file, and you can even share the file with somebody else and they can open it and check your design, particularly in this case, the use case diagram which captures requirement in the system. So we encourage you to go ahead and try this out. See you in the next lecture. Thank you.